We are looking at the meaning and uses of truth table. The meaning and uses of truth table. Now we see that a truth table is an array of T's and F's. You know, a truth table contains an array of T's and F's, which means you have a distribution of T's and F's in equal proportion to the statements involved in either to the variables involved in the statements or arguments that are present on that table. So there is a very important formula that we need to take note of, and it is 2 raised to the power n when we construct a truth table, because you need to know the number of rows and columns that you are going to have. The number of columns that you will have, there are a number of columns that you will have and a number of rows that you will have. Right? So here we have the formula 2 raised to the power n. It helps us to determine the number of rows that we will have on our truth table, where n is the number of variables. The number of variables, that's the number of statements involved in what we are supposed to analyze. So if, for instance, you have 2 statements involved, you are going to have 2 raised to the power n. 2 raised to the power n. And 2 raised to the power n, since there are 2 statements and n is 2, we'll have 2 raised to the power 2, which is 2 raised to the power 2. And 2 raised to the power 2 is the same thing as 2 times 2. And 2 times 2 is 4, which means we are going to have 4 rows. If you have 4 variables there, then you are going to have 2 raised to the power n would be 2 raised to the power 4. And then you are going to have 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. That's how it goes. If you have 3 statements there, then you have 2 raised to the power 3, which will give you 2 times 2, 4, 4 times 2, 8. It means you're going to have 8 rows. That is how it goes. So we just need to take note of this formula, 2 raised to the power n, where n is a number of variables. So in distributing T's and F's, we need to make sure that we do so equally, that T's are distributed equally and then F's are distributed equally. And it is advisable that we begin with T's and then end with F's. It's not as if you begin with F's that you'll be wrong. No, but it's just for the sake of consistency and uniformity. So we'll begin with T's and then we'll end with F's. If you decide to begin with F, you will not be wrong. But for the sake of consistency, we'll say begin with T's and then end with F. I'm going to explain all this shortly. So what do we do with truth tables? We can use the truth table, a truth table, to determine the truth conditions of logical connectives. We've done that already. Where we try to use the truth table to show when show the truth condition of conjunctions, and then we're able to arrive at the conclusion that a conjunction is only true when both conjuncts are true. And then we talk about disjunction is only false when both disjuncts are false. And then a conditional statement is only false when the antecedent is true and the consequent is false, otherwise it's true. And then a biconditional statement is true when the components have equal values, which means when they are both true, it is true. When they are both false, it is false. We have been able to use the truth table to determine this. So you can go back to your materials and then look those ones up. So we'll be using the truth table to characterize statement forms as tautologous, contradictory, contingent, or logically equivalent. We'll be doing that. We can also use the truth table to determine the validity or invalidity of arguments. But let us take note of this before we begin. Let's take note of this. When you use a truth table to characterize statement forms as either tautologous, contradictory, or contingent, you must know this, that it is tautologous. A statement is said to be tautologous when it is true under all interpretations. In all possible worlds, when it is true, then we say it is tautologous, which means under the major connective of your truth table, when they are all true, you say tautologous. But when they are all false, you say contradictory. Contradictory when they are all false under all interpretations. But when you have a combination of truths and false, then you say it is contingent. It's contingent. I'm going to explain this to us, but just take note of the notion of tautology, contradiction, and contingency. Take note of them. It is tautologous when they are all true, contradictory when they are all false, and then contingent when it's a combination of truth and false. So, we have previously used truth tables to determine the truth conditions of logical connectives. So let us now use truth table to characterize the following statement forms as tautologous, contradictory, or contingent. So we'll be looking at this, P conditional Q. We'll try to see, we want to know whether this statement is either tautologous, contradictory, or contingent. We'll be looking at P conditional Q, conditional P, conditional P. We're looking at P dot Q, wedge Q, wedge negation P, as well as negation P dot Q, conditional P. We'll be looking at all these. Let's begin with this. P conditional Q. P conditional Q. This is the statement we are trying to look at now. We want to know whether this statement is either tautologous, contradictory, or contingent. So you have to begin with the formula. You know, we said that we'll be guided by this 2 raised to the power n, where n is a number of statements. So you have P and Q. P and Q, there are just 2 variables here. P and Q, these are the 2 variables, which means we are going to have 2 raised to the power 2 because n is 2. That's why we have 2 raised to the power n is equal to 2 raised to the power 2, and 2 times 2 will give us 4. So we have 4 rows. You plot your table this way. This is row 1, row 2, row 3, row 4. You don't need to put these ones here, but it's just for the sake of explanation that I put it here. And this is the complete table for this statement. This is the complete table for this statement, what you have here. I just want to explain to you, that's why I'm having 2 tables here. You see, I did not impute values here because I want you to know how I come about these values. So we'll take them step by step. Now, we have P conditional Q. We've already said that we're going to have 4 rows. So we have row 1, row 2, row 3, row 4. So we try to distribute T's, like we said, and F's equally. We'll do that equally. We ensure that P has equal number of T's and F, and then Q has equal number of T's and F's. So here, you begin with true, true, and then false, false. You've distributed T's and F's to P. You come to Q and also distribute T's and F's in equal measure. So you're not going to come here and say true, true, false, false. Again, you arrange it in such a way that you are going to have true, false, true, false. But when you count, you see that you have 2 T's, 2 F's. And here you have 2 T's, 1, 2, and then 2 F's, 1, 2. So you have distributed T's and F's equally to this statement and this statement here, this variable and this variable. So it is now up to you to determine the value of this connective, the logical connective. It's up to you to determine the value of this logical connective. And it is time for you to now rely on your knowledge of the truth values of logical connectives. You can't forget that. You now have to rely on your knowledge of logical connectives. So when is a conjunction true? When is it false? When is a disjunction true? When is it false? When is a conditional true? When is it false? When is a biconditional true? When is it false? When is a negation true? And when is it false? You see that? You have to do that. This is a conditional now. It's a conditional statement. So you have to rely on your knowledge of the truth values of logical connectives in terms of conditional statements. So let us come here now, because in imputing this the values here, I just want to make it clearer. That is why I have to plot it here again. So we have P, true, true, false, false, and then Q, true, false, true, false. So in determining the values of this connective, what you do, you combine this value and this value to get this. So this is a conditional statement. A conditional statement is false when the antecedent is true and the consequent is false. Here, the antecedent is true, the consequent is true, so it is true. Go back and check the table we drew previously. When the antecedent is true and the consequent is true for a conditional statement, it is true, so we put true here. When the antecedent is true and the consequent is false, it is false, so we put false here. When the antecedent is false and the consequent is true, it is true. When the antecedent is false and the consequent is false, it is true. Remember we said that a conditional statement with a false antecedent is necessarily true. So having done this, having plotted this table, this truth table, you now inspect this major connective. You inspect the connective for the conditional to see whether, remember what we said? Remember what we said here, that when the values under the major connective, when they are all true, we say tautologous. When they are all true, under all interpretations, we say tautologous. When they are all false, under interpretations, we say contradictory. When you have both true and false, we say contingent. So we can come back here now to inspect our table under this. We see we have true, we have false, we have true, we have true. So there is a combination of true and false. So for that reason, this statement is contingent. Contingent. You just say contingent, that's all. So it's not tautologous, it's not contradictory, but it is contingent because it's a combination of true and false. And then we have this. P conditional Q, conditional P, conditional P. So you see here we have two variables. We have P, we have Q, and then P, P is the same variable. So you have P, 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 and then we have Q. So P, Q. So there are just two, P and Q, which means we're going to have 2 raised to the power n, and then 2 raised to the power 2, 2 times 2 will give us 4. So we're going to have 4 rows, that's it. So we have row 1, row 2, row 3, row 4. Like I said, there is no need imputing those rows there. It's just for the sake of explanation that I did that. Here, there is no need imputing these rows. Alright, so you distribute your T's and F's equally. Very important. Distribute that equally. And then you can say, you say true, true, false, false. The next one will therefore be true, false, true, false. You see that? And then we have to now determine the value of this. We have to combine all this with this to get this. But mind you, we have P here. The value for P is true, true, false, false. We have to bring the same values and put it here because it's the same variable. So we have true, true, false, false. We also have P here. We have true, true, false, false. If for any reason we have Q here, we would have come here to say true, false before, because Q is true, false, false. But we don't have that. So all the same values you have for P will continue to be the same values for P anywhere you have them. So that's important. So let us now try to impute values for the connectives. The connectives, and I try to plot a different table to explain that. So you combine the values here and the values here, which is the values for P and the values for Q, to get this, because this is the parenthesis. Remember we said you have to begin with parentheses. You see that? Parentheses. You have to begin with this parenthesis. When you are done solving for the parentheses, you can then move on to brackets. Look at it. This is the bracket. You can then move on to solve for this bracket. When you are done with the brackets, you can then move on to braces. So let's begin with parentheses. here. So you combine this and this to get this. It's a conditional statement. Antecedent is true, consequent is true, it is therefore true. Antecedent is true, consequent is false, it is therefore false. Antecedent is false, consequent is true, it is true. Antecedent is false, consequent is false, it is true. Remember, a conditional statement with a false antecedent is necessarily true. So here, these are the values we have. But we are not done with the expression. There is still another connective here, which is to now move to the brackets. This is the major connective for the brackets. So we now have to give values to this. So now you need to combine the values of this parenthesis, which is this, and this P to get this. Get it clearly. You combine these values and these values to get values for this. But when you want to get values for this, you have to combine the values under this connective and this P to get the values for this. When you need to get the values for this connective, you have to combine the values for this and the values for P to get this. So that is what we are doing here now. We already have the values for these parentheses. So we combine the values for this parenthesis and the values for this P to get this one. So which means we'll be having antecedent is true, consequent is true, therefore we have true. Antecedent is false, consequent is true, therefore we have true. A conditional statement with a false antecedent is true. Antecedent is true, consequent is false, we have false. Antecedent is true, consequent is false, we have false. So all these ones, we now have values for this. True, true, false, false. That's what we have for this now. This is not the answer to the whole expression because this is the major connective. This is what connects everything here in this bracket and this statement that has to do with these braces. So we are interested here on this because this is the major connective. The values here is what determine what will be our response in terms of answer to this statement. So we have to combine these values now and the values for P to get this. So antecedent is true, consequent is true, this is true. Antecedent is true, consequent is true, this is true. Antecedent is false, consequent is false, this is true. Remember, a conditional statement with a false antecedent is true. A conditional statement with a false antecedent will also be true. So when you inspect this table now for the major connective, because it is this connective that connects everything here and this statement. So this is the major connective. It is the values under this that will give us the response, the proper answer to this question. When you inspect this, you see that they are all true. The values here are all true. So for that reason, this statement is tautologous. Tautologous. Very important. So let's move on. We have P dot Q, wedge arrow, wedge negation P. So how do we do that? How many variables do we have here? We have P, we have Q, we have arrow, then we have negation P. Negation P is the same variable as P, just that it's negated. So we're having P, Q, arrow. So there are three variables. There are three variables here. So which means that we're going to have 2 raised to the power n will be 2 raised to the power 3. And then we'll have 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. We're going to have 8 rows. 8 rows. So that's why we're having row 1, row 2, row 3, row 4, row 5, row 6, row 7, row 8. There are 8 rows here. So we want to distribute values here. Like I said, we are distributing values here, and then in trying to distribute values for the connective, I plotted another table for it. Otherwise, you don't need to plot 2 tables. This is the proper table for this statement. Once you have this table, you are okay, you are good to go. But it's for the sake of explanation that I'm plotting 2. I'm plotting the table for the statements and then the table for the connective, so that we can see how we come about the truth table step by step. So we distribute T's and F's equally. Since there are 8 rows, we are going to have true, 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 4 T's, and then false, 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 4 F's. The next statement now we have true, true, false, false, true, true, false, false. And then the third one will be true, false, true, false, true, false, true, false. You see that? When there were just 4 rows, we had true, true, false, false, true, false, true, false. Now we have 8 rows. We're going to have true, 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 false, 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 false. And then the next variable will carry true, true, false, false, true, true, false, false. And then the third variable will carry true, false, true, false, true, false. If there are 16 rows, it's the same thing. We are going to have 8. Which means you have 8 T's, 8 F's. The next variable will carry 4 T's, 4 F's. The next variable will carry 2 T's, 2 F's, 2 T's, 2 F's, just like that, and then 1, 1, 1, 1, 1, 1. That's how you distribute your values in equal proportion. So having done this, we can then determine the values of the connectives there. So you need to combine the values here and the values here to get this. This is a parenthesis. We said start working from parentheses. When you are done, you go to brackets, and when you are from brackets, you go to braces. So there are 2 parentheses here. Look at, there is one here, there is another one here, which means you have to solve for this parenthesis. When you are done, you come here to solve for this parenthesis. When you are done, you now combine the values of this parenthesis and the values of this parenthesis to get the value for the bracket. Because this wedge is the value for the bracket. It's what is combining this parenthesis and this parenthesis and covered within the scope of these brackets. So let's begin with this. You see, we combine the values here and the values here, the values for P and the values for Q to get the conjunction, the dots. When we are done, we move on to this, the values for R and the values for negation P. And then we come in here. But take note, please. Take note, please. I told you how we got the values for P here, 4 T's, 4 F's, and then the values for Q, we distributed them in 2's, true, true, false, false, true, true, false, false. The values for R, true, false, true, false, true, false, true, false. Now we have negation P. If this were to be P, like we saw previously, the same values we have here will be what we have here. We'll be having true, true, false, false, true, 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 false, 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 false. That's what we would have had here. But this is a negation P, which means if this is true, negation P will have to be false. If P is true, negation P will be false. P is true, negation P is false. So if you have true, 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 false, 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 you have to come here and then you have false, 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 true, 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 true. Because this is a negation. So, how did we come about this? You combine this and this. This is a conjunction. A conjunction is true when both conjuncts are true. Don't forget that. You have to have these values, or the truth values of logical connectives at the palm of your hand. You just have to have them. Otherwise, you can't resolve these problems. So, this is a conjunction. It is true when both conjuncts are true, which means if this statement is true and this statement is true, this value will be true. That's why we have true here. True, true will give us true because it's a conjunction. True, false will give us false. A conjunction is only true when both conjuncts are true. Any other condition is false. True, false is false. False, true is false. False, true is false. False, false is false. False, false is false. It is only true when both conjuncts are true. When both conjuncts are true. So that's how we have these values. So we are done with this parenthesis. You can then move on to the next parenthesis before you come to the brackets. For this parenthesis now, we have true, false. A disjunction. This is a disjunction. It's a wedge. A disjunction is false when both disjuncts are false. So this is true and this is false. It's therefore true. This is false and this is false, so it is false. Because a disjunction is false when both disjuncts are false. So this is false. True, false will give us true. False, false will give us false. A disjunction is false when both disjuncts are false. So true, true will give us true. False, true will give us true. True, true will give us true. False, true will give us true. So we have the values for this parenthesis, which is this wedge. So we combine the values for this wedge because this is the value for this parenthesis and the values for this dot conjunction because this is the value for this parenthesis. You combine the values of this parenthesis and the values of this parenthesis to get this wedge, which is the value for the brackets. So we combine the values in the blue here and the values in the blue here to get the values in what I painted red here. You see that? So it is a wedge, a disjunction. A disjunction is false when both disjuncts are false. So true, true will give us true. True, false will give us true. False, true will give us true. False, false will give us false. False, true will give us true. 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 So you inspect the values under the major connective because this is the value under the major connective. This is the parenthesis and this is another parenthesis joined by this. This is what is joining the two disjuncts. We have true and we have false. So there's a mixture of T's and F's. So we therefore say it is contingent. Contingent. All right. So we have this negation P dot Q dot Q conditional P. Negation P dot Q dot Q conditional P. So we have this. We have P, Q, Q, P. So there are just two variables there, P and Q. So we're going to have 4 rows because 2 times 2 will give us 4. Now, we said that you begin with T's and end with F's. That's because they are positive. Here, this is negative. It's a negation, negation P. So you can reverse it and you have F and then T. So negation P, you therefore have false, false, true, true. And then Q, therefore be true, false, true, false. Now this is Q. So Q must take the values of Q anyway you have it because we already have values for Q here. You just repeat the same values for this Q. That's why we have true, false, true, false. And then this P, mind you, negation P is false, false, true, true. So P will therefore be true, true, false, false. We can then provide values for the connectives. So we have one parenthesis here, we have another parenthesis here. You solve for this parenthesis. When you are done, you solve for this parenthesis, and then you solve for the brackets. That's how it's done. So let's come here now. We have values here and the values here. This is a conjunction. Remember, a conjunction is true when both conjuncts are true. So false, true will give us false. False, false will give us false. True, true will give us true because a conjunction is true when both conjuncts are true. True, false will give us false. You move to the next parenthesis. True, this is a conditional statement. It's a conditional. Remember, a conditional statement is false when the antecedent is true and the consequent is false. Otherwise, it is true. So you have true, true to give you true. False, true to give you true. Remember, a conditional statement with false antecedent is necessarily true. True, false will give you false. The antecedent is true, the consequent is false, therefore it is false. So false, false will give us true. We then have the values for this parenthesis. You now have to combine the values for this parenthesis and the values for this parenthesis, a conjunction and a conditional statement, to get this conjunction in red. So you combine the values in blue to get for this conjunction. A conjunction is true when both conjuncts are true. So false, true will give us false. False, true will give us false. True, false will give us false. False, true will give us false. A conjunction is only true when both conjuncts are true. There is no place here where both conjuncts are true. So we have all the values here they are false. All the values, they are all false. Look at that. All the values are false. So, take note of that. That is why, for this reason, we say contradictory. Contradictory. So, we move on to logical equivalence. Logical equivalence. So, two statements are logically equivalent when they have equal values. When they have equal values, then they are logically equivalent. When they have equal values, it simply means that they can replace each other in an argument. That's it. It means they are the same. They can replace each other. They can take the place of each other in an argument. They are the same. Yes. So you'll be given two statements, and then we'll ask you whether or not the two statements are logically equivalent. Are they the same? That's what we'll ask. So you have one statement and another statement. You have to join them together with a biconditional, with a triple bar. You know, that's a symbol for logical equivalence. Triple bar. So you join them with the triple bar and then plot a truth table for them, and then if they are all true, if the values under the triple bar are all true, when it is tautologous, then they are logically equivalent. When not tautologous, they are not logically equivalent, which means if they are contradictory, if they are contingent, then they are not logically equivalent. The only time when two statements are logically equivalent is when the values under the major connective are tautologous, when they are all true. When they are all true. So let's take a look at this. We have negation P dot Q. Take a look at this. You see the whole of this parenthesis has been negated, which means everything in this parenthesis is within the scope of this negation. So if you negate anything here now, it affects everything here because it's this and this that has been negated all together. Remember. And then we have these ones. They are negated individually. Remember, both not and not both, right? So we have just two variables here, P and Q. So we have true, true, false, false. And then we have true, false, true, false. This is P, but it's negation P. So since P is true, true, false, false, negation P will be false, false, true, true. Since Q is true, false, true, false, negation Q will be false, true, false, true. You see, that's how you distribute your values, your T's and F's equally. Having done that, you have to now provide values for the connectives. So let's come here now. You begin with parentheses, like I said, and then you can go to the next parenthesis. It is when you are done, you come to the logical connective that connects both this component and this other component. You know, when you join two statements with a triple bar, logical equivalence, they become components. So remember, take note of this. I want to say this. Here we said this statement and this statement. Don't make the mistake of representing this and with a dot. We know that and is a dot, but here, this and here does not mean a dot. We are just saying we want to know whether this statement and this statement are logically equivalent. So in order to know whether this statement and this statement are logically equivalent, you must join them together with a triple bar, with a biconditional sign. That is why we have this statement here, and then we have the biconditional sign, and then this other statement here. So we begin with the parentheses. It's a conjunction. A conjunction is true when both conjunctions are true. This is true and this is true, therefore this is true. You have true, false, it is false. You have false, true, it is false. You have false, false, it is false. You can then, now, watch this. The whole of this parenthesis, the values for this parenthesis, these are you have them here. But this parenthesis has been negated. You see, has been negated. This is negation, this parenthesis. So which means that all the values here must be negated to get the values for this negation. So if the value for this conjunction here is true, to be negated, it will be false. False to be negated will be true. False to be negated will be true. False to be negated will be true. So this becomes the values the major connective, the values now for this parenthesis. So if you want to look for the value of this now, we'll be looking at this negation because that is what it is. Then you move on to the next. For this, they are negated individually. So it's not like there is a negation that is within the scope of all of them. They each carry their own negation. So you just combine this and this to get this. This is disjunction. The disjunction is false when both disjuncts are false. So this is false. False true will give you true. True false will give you true. True true will give you true. A disjunction is only false when both disjuncts are false. Otherwise, it is true. You combine the values for this and the values for this now, the negated one now, because everything here has been negated. You combine the values here with the values here to get this. So this is a biconditional sign. We say that a biconditional statement is true when the components have equal truth values. When they are both true, it is true. When they are both false, it is true. Don't forget. When they are both true, it is true. When they are both false, it is true. When you have true false, it is false. You have false true, it is false. So this is false and this is false. They are both false. So it's true. This is true and this is true. They are both true. So it is true. This is false. This is true, sorry. This is true and this is true. They are both true. So it is true. And here, this is true and this is true. They are both true, so it is true. When you inspect the values under this biconditional sign, you see that they are all true. For that reason, this statement and this statement are logically equivalent. So this statement is equivalent to this statement. Mind you, this one carries a dot and this one carries a wedge. If you change this one to a dot and you plot a truth table for them, they will not be logically equivalent. All right. So we have this statement and this statement. You plot a truth table. You have PQ and then PQ negation P negation Q. So there are two statements there, two variables there. So it means you're going to have 4 rows: true, true, false, false, true, false, true, false. This is P. If P is true, true, false, false, negation P will be false, false, true, true. If Q is true, false, true, false, negation Q will be false, true, false, true. See that? So you solve for these parentheses before coming to solve for this parenthesis, and then you combine them to get this major connective, which is a triple bar. This is a conditional statement. True, true will give us true, because for a conditional statement, it is only false when the antecedent is true and the consequent is false, otherwise true. So true, true will give us true. True, false will give us false. Antecedent is true, consequent is false, it is false. False, true will be true. False, true will be true. And then when you come here, you see that false, false is also a conditional statement. False, false will be true. False, true will be true. A conditional statement with a false antecedent is true necessarily. So true, false, antecedent is true, consequent is false, will be false. True, true will be true. So in order to get this value now, you have to combine this, the blue here, and this blue to get this. So this is a triple bar. When the components have equal values, it's true. When not, it's false. We have true, true, it is true. We have false, true, so it is false. This one is false, this one is true, so it is false. So we have true, false, it is therefore false. And then we have true, true, it is true. When you inspect, you see that they are not all true. They are not all true, so they are not logically equivalent. They are not logically equivalent. You have true and false here, which means it's only when they are all true that you say they are logically equivalent. So this is very important. So I need you to pay attention to all these. Go over the explanations once again, or as many times as possible, and ensure that you follow through with everything that we are saying. So pay attention to the self-assessment questions. Look at that. You have to do that looking at the recommended text. And thank you.